Hello everyone, my name is Ajay. So in this video I'm going to explain you about the problem called as longest increasing continuous subsequence. So if you are given an array, you have to actually return the longest length of the increasing subarray, which is in a continuous order. So here if you can see, I'm having this array. So you can see 1, 3, 5 are in the increasing order. Again it is decreasing at 4, but before that 1, 3, 5 are in increasing order. So I'll add down it here. And again from 4 it is again increasing till 7. Okay. So here if you can see, this is of length 3 and this is of length 2. So I have to return 3. So the problem is to just return the longest length of the subarray which is in increasing order. So that is the problem. So let's see how we can actually solve this one. So for solving this, I want to have count variable to 0. I will assign count variable to 0, and I will have max variable to 0. Okay, I'll use these two variables for solving this. Actually, for solving this, I will iterate. Let me actually write down here. So for iterating this array, I will use this pointer I. So I will write it here, I plus 1, count and max. So the idea is like each and every iteration I want to check the ith element with I plus 1 element. So if ith element is less than I plus 1th element, that means it is in increasing order. So at that time I will increment the count. So whenever the ith element is greater than the I plus 1th element, like here 5 and 4, so then that means it is not in the increasing order anymore. So at that time I will reset the count to 0. So that way again the count will start from 0 from the next ith element. So for each iteration I will update the max value, which will be max of count and current max. So in each iteration I will also update the max value. So that way by end of the iteration I will get the max count of the array in this max variable, and I can return that one. So let me actually walk through this array and show you how exactly it works. So initially I is at 0. So I want to iterate it till only n minus 1. Why? Because I'm comparing the ith element with I plus 1 element in the each iteration. So if I iterate till the last element, then it will throw error for me. Why? Because I plus 1 would be 5, which is not the index of this array. For that reason I will iterate till n minus 1, which is 3 in this case. So first 0 iterations, first iteration, second iteration and third iteration. So I'm just writing the iterations here. So first, when I is equal to 0, I plus 1 would be 1. So I will compare the ith element and I plus 1 element, which is 1 and 3. So 1 is less than 3, so that means it is in the increasing order. So I will increment the count by 1. So currently count is 0, so I will increment count, so that will become 1. And now I'll get the max value. Max value is max of count and max. So max of count 1 and current max value is 0. So that is nothing but 1. Okay. Now I got the max value. Now in the next iteration I is 1 and I plus 1 would be 2. So now I will compare both elements, which are 3 and 5. So 3 is less than 5. That means it is still in the increasing order. So I will increment the count again. So which will become 2. 1 plus 1 is 2. Now I will get the max again. So current count is 2 and current max is 1. So which is nothing but 2. Okay. Now in the next iteration, when I is 2, I plus 1 will be 3, and I will compare these two elements now, 5 and 4. Here if you see 5 is greater than 4, that means it is not in the increasing order anymore. So at that time I will actually reset the count to 0. Okay, and I will get the max now. So max is count which is 0, and max, the current max is 2, so that is nothing but 2. Okay, okay. So again in the next iteration, when I is 3, I plus 1 will be 4, so which is 4 and 7, so they are in the increasing order. 4 is less than 7, they are in the increasing order. Now I will increment the count. So currently count is 0, so after incrementing it will become 1. I will get the max again. So max is, our current count is 1 and current max is 2, which is nothing but 2. So this is the answer. So after iterating all the elements of this array, you will actually get the max value. So that will be the answer. So you have to finally return max plus 1. So we have to return max plus 1. Why? Because so this max count here is just the number of conditions. So here in this array we are actually having 2 conditions, like 1 is less than 3 and 3 is less than 5. So that max count is the number of conditions. So while returning I am adding plus 1. Why? Because if you are having 2 conditions within an array, that means we are having 3 elements. So for that reason I am just adding 1 to the max and returning that finally. So let me implement this and show you how exactly it works. So I've written the function prototype here. So it will return an integer which is the max length, and it takes array of integers. So initially actually I want to check if array dot length equal to 0, then that means there are no elements in the array, so I will just return 0. Okay, and else I want to declare these variables, which is int count equal to 0 and int max equal to 0. Okay, and now I want to start looping and I want to iterate through the array. So for that I will use for loop for int I equal to 0, and I just want to loop till n minus 1 element. So I will use I less than a dot length minus 1 I plus plus. Okay, so in each iteration I will be comparing ith element and I plus 1 element. So for that I will use if condition, if ar of phi is less than ar of phi plus 1, then so if ar of phi is less than ar of phi plus 1, we are actually incrementing the count. So then I will just increment count by 1. Okay, else, so in this scenario, when ith element is greater than I plus 1 element, then we are resetting the count. Why? Because it's not in the increasing order anymore. So for that reason I will just reset the count. So count will start incrementing from 0 again in the next iteration. So for that reason in the else block I will make count to 0. So whenever in this array, whenever there is an element where ith element is greater than I plus 1 element, then I am just resetting the count to 0, so that the count will start again incrementing from 0 from that iteration onwards. So that way we will get the maximum, we can keep track of maximum length of the subarray, which is in the continuous increasing order. So else I will make count equal to 0, and in each iteration I want to also update the value for max. So for that reason I will use max, which is max equal to which is nothing but max of count and current max. So that is nothing but I'll use a condition statement here. If max is greater than count, max is greater than count, then I will assign max, else I will assign count to max variable. So this is nothing but it's like max of count and current max. So what? So here if you can see, it's a conditional statement. If max is greater than count, then I'm assigning max value to max, else I'm assigning count value to max. That way the max will be having always the maximum value within count and the current max. Okay, I will close the for loop, and finally I will return max. Okay, so that's all about the code, friends. And coming to the time complexity, so here we are using the for loop, which is iterating almost through it, which is iterating almost n times, where n is length of the array. So the time complexity would be big O of n, linear time, and this space complexity would be the constant space. Why? Because we are not using any temporary or anything for doing this operation. So space complexity would be big O of 1. So that be all, friends. If you have any questions, you can actually post them in the comment section of this video. And also, if this code is not clear, don't worry, I will actually post the link for this code in this description of the video. That be all. Thank you for watching my video. Thank you.